Let me get
Action. That way for anyone that's gone, tomorrow, or not tomorrow, but today, they can get video of this. And or if at any time too, by the way, if anyone ever wants a video from class, just please let me know. I'll be happy to send you the link. I have the collection of
You could just search
videos.
your name on YouTube.
Huh?
You could just search your name on YouTube.
Yeah, I think you could. My videos are public. I don't know if it'll show up that way or not, but I mean, I know all the videos I publish are public, so I mean, you can find them, so, yeah. Anyway, okay. So from our lab, obviously we had a piece of metal, 5 different pieces of metal. Okay, we plotted them on a graph. Now, for the most part, did all of those points that you made, again, for the most part, not saying it had to be perfect, for the most part, did the points make a straight line, or fairly straight line?
fairly straight.
No for some, fairly straight for some? Okay. Well, how about this? I'm going to take your guys' group as the example there, Tyler.
Okay.
Because I think with your guys', I was noticing something. All right. When you guys did your math, and this is not a bad thing, I'm just saying, when you did your mass divided by your volume for each piece, not that every group had to do that. Well, I think you didn't have to do it for your whiteboard, so I'm just saying it's one thing I noted on your whiteboard. When you did the mass divided by volume for each piece, what did you notice about each of those quote-unquote mass divided by volumes for each one?
They're pretty dang close.
They're pretty dang close. Okay, so of those pieces of metal that you got, obviously, again, same kind of metal, all different lengths. Why do you suppose every time that you would do the mass divided by volume for them, why do you suppose the number came out pretty much the same every single time, Rodney?
They have the same material.
Which means?
Which means that they have approximately the same amount of density.
Exactly, yeah. So density is a property of a respective material. Okay? So when you found the slope of your line, y2 minus y1 divided by x2 minus x1, aka mass minus mass, divided by volume minus volume, you got density, which you could then measure. Another question I'll bring up here in a little bit. In fact, I'll probably save that at the end here, so maybe we can tinker with it some tomorrow. Density. So density is mass divided by volume. It is a property that is characteristic for a material. Now, when you did the mass divided by the volume for the different piece, or the different substance that you had, how did its mass divided by its volume compare to your 5 pieces of the same type of metal? So like whether you did rebar, or like the plastic block, the wood block, whichever you did, something that was different other than that shiny metal. How did its density compare to the density of the shiny metal? Karen? Okay. Why do you suppose it was higher? It's a different material. So if you have the same material, you're going to have the same density. If you've got a different material, you're going to have a different density. Same material, same density. Different material, different density. Okay? So like on your line here, you'll notice as the line goes up, the mass is gonna be greater and the volume is gonna be greater. But obviously point 2 and point 1, if you take their respective masses divided by their volumes, they're gonna be the same. So even though you have a bigger piece of a substance, if it's the same material, it's gonna have the same density. If it's a different material, it's gonna have a different density. Okay, and then as you guys are suggesting, when you have the water, say you had the green, you had two rubber balls in there, we'll call them. And I know I'm not making them quite the same size, I'm trying to, but. You had one that was halfway, the other that was different there. You're saying that the two of them, from what I could tell from the whiteboards, maybe I need to hear it again from you. Why were these two at different levels in the water again? Sammy?
There were two different materials.
Two different materials, which means
At
different densities. So, in order to get them to be the same level, we've got to change the density of them. So, let's say if I wanted this one to go up. And we know that density equals mass divided by volume. There's actually two things I could do to this one. I could either change its mass, or I could change its volume. In this case here, let's say if I decide to keep the mass on this ball the same, what am I going to have to do to get it to float then if I keep the mass the same? Make it what? Well, a thought on that then. Okay, let's say if on this one, we'll say the density is 10 divided by 5, which equals 2. This one is currently 10 divided by 2, which equals 5. So the bottom one's 5, the top one is 2. This is just a hypothetical situation, okay? I keep the mass the same, but if I decrease the volume, say I change it to 1, now what happens to my density? Huh? Yeah, it's going to go down because it got greater. So actually, what am I going to have to do to the volume instead? Make it bigger. So if I want this volume to go higher, I'm going to have to make it bigger. That's one idea. Or, let's say if I want to get this other ball to come down. If I want to get this other ball to come down, I'm going to have to do one of two things. Either I'm going to have to make it smaller, but obviously if I've got a ball I really can't do a whole lot to it. I guess I could probably try to scrape away some of the rubber. Or what I could do is I can change the mass on it. See, if I make it more massive, I change that mass to 25. Now I've changed the density. Now I've made it 5, and it's going to come down to this level because I've made it more dense. So if you want them at the same level, they've got to have the same density. Obviously, you do one of two things: either change the mass on it or change the volume on it. Okay? So actually, from the options that we had there, let's see, what can Sam do to make the ball float like the ball on the right? Okay, so ultimately we had to change this one here. So option A was use a larger ball out of the same material. Well, as we just mentioned with a larger ball, if I make this number bigger, again, how's that change density? Does it make the density greater or lesser? If I make this number 10, that would be making the volume bigger. What's that do to my density? Smaller. Okay, so I don't want that. So option A is out. Option A is out. We can't use a larger ball, the same material. That's going to lessen the density. It's going to make it float more. Okay. Option B is use a smaller ball out of the same material. Well, problem with that. Again, if I've got the same material, in other words, if I keep this material the same, it's going to have the same density. So whether it's larger or whether it's smaller, does the density change? No. Not if I use the same material as it's currently made of. All right, C and D. Use a ball of the same size. Okay? So I can keep it 5, the same size, make it out of a more denser material. Okay, so I got to change the density on it. Keep the same size, 5. I make it more massive. Voila. I've now just made it the same. So as you guys figured out, and you guys pretty much came to that conclusion from the lab, if you make it out of a denser material, you're going to get this one to sink like you want it to, okay? Or obviously, if you keep the same ball and you attach a weight, that's also increasing the mass. That would also work, okay? Let's see, anything else in terms of notes from this? Now, if I were to graph that different material on here that you took the mass divided by volume for, would it have the same line as this? Why not? More dense, different density. Okay. So that other material that you had, depending on whether it was less dense or more dense, if it was less dense, it had a line like so. If it was more dense, a line like that. If you have a greater density, that means you have more mass per volume. If you have a lesser density, that means you have less mass per volume. So your slope would be different if you have a different material. Okay, lastly, why do you suppose, what would this mean right here, this point here? 0, 0. Nothing. Nothing. You've got nothing. If you've got nothing, you have no density. Okay? I will finish with that tomorrow. And what I want to do is take a look at the idea. We didn't finish on the idea of, is there a difference between a centimeter cube and a milliliter? Ponder that thought. Okay? No assignment tonight. Assignment will be assigned tomorrow. Due for Friday. Also, take some time to work on journals in addition to doing that quick activity. See you later. Have a good rest of the day.
Good luck, people of Video World.
Goodbye.